or ask you to elaborate a bit on the quality needed for an ADS-B sensor, because ADS-B is a generic term, first of all. But could you elaborate a bit on the quality that's behind this system in terms of reliability, spatial differences in different navigation or positioning sources, etc.?
Ho cleared opponent. Thank you for your kind words and thank you for your question. So your question relates to the ADS-B system and its importance in a decentralized air traffic control. Indeed, what you need for decentralization is some form of inter-aircraft communication so that the aircraft state variables can be exchanged between the aircraft, making it possible for each aircraft to have sort of an awareness of all the other aircraft near to you to detect conflicts and also resolve those conflicts. And the currently available system that is being proposed to do this inter-aircraft communication is indeed ADS-B. I have to confess I am not an ADS-B expert, but we have done some research alongside this thesis by one of my MSc students who looked at the minimum operating performance specifications for ADS-B and checked whether conflict resolution using the conflict resolution algorithms that we used in this study, the state-based conflict detection and the MVP conflict resolution algorithm, if their performance was affected by ADS-B performance. And what we found was that it really wasn't. So then what we said was, okay, supposing the ADS-B receiver is only having half the range and half the transmit power for some reason compared to what the MOPs say. And again, we did the simulations, and again, this combination of state-based CD and MVP was able to handle all the conflicts. Of course, the conflicts were sometimes closer than before, but the algorithm was robust enough to deal with how should I say, all the uncertainties that occur in ADS-B. So I'm fairly confident that ADS-B is good enough, the minimum specifications is good enough to realize self-separation in today's commercial air traffic.
Okay, thank you. Herr Director, the next question is related to proposition number 4.
May I ask the promovendus to read proposition number 4, please?
So proposition 4, to maximize the capacity of decentralized airspace, it is necessary to optimize the selected airspace design, the selected algorithms for tactical conflict detection resolution, and the pairing between these two elements.
Thank you.
Please.
Yes. The question, we have already touched this capacity question, and I'd like to ask you also to elaborate a bit about the, well, first one side of your spectrum is a self-separation, which is part of basically your thesis, and the other part or the other edge could be like a centralized airspace system like sectorless or a different system which is centralized. And typically the ATC system is designed to work on the declared capacity with a target level of safety, which is typically 10 to the -8 collision risk. Could you elaborate a bit on what your system as a decentralized system is capable to meet the 10 to the -8? Is that a right approach to design the system to meet a target level of safety, or rather taking whatever is available as a system safety at the end?
Okay, so I think the question has to do with do you design a system to meet a certain safety standard, or do you see what the system is capable of and it can meet the safety standard? I would say go with the second one. Try to see what the system is capable of and see if it can meet the safety standard. The reason is safety standards are somewhat arbitrary. They are sort of an expectation about society on what is acceptable for a conflict. And in my opinion, this acceptability is somewhat arbitrary. It is based on technical capability, but it's also based on, let's say, what society, how the frequency of air crash accidents for society. On the other hand, if you look at it from a purely technical perspective, any system that you design should be able to meet this safety requirement. So the system should, and the safety requirement is not defined because of the system, it's defined because that's what we want. It's not, indeed the system results in the safety, but it's not, let's say, this whatever system you use, that safety has to be resulted. So for that reason, to generate different options for structuring traffic, it would be better to start a little bit more fundamentals, looking at what causes conflicts, what causes efficiency to decrease, and try to figure out which combination of input parameters could be used for a particular airspace design to then realize the safety target level of safety.
Okay, thank you. I would continue with another question which is related to that, but this question would also be addressing proposition number 5, Herr Director.
Mr. Promovendus, would you like to read proposition number 5?
Proposition 5. Widespread adoption of unmanned and personal aerial vehicles will require an urban airspace design that provides a level of planning flexibility that is similar to that offered today to road traffic.
So my first part of my question is, if we have these new type of vehicles like unmanned and personal area or urban air taxis or whatever you call them that fly in our urban environment, I would probably, you would probably agree that we only can go with your approach to safety, because we will never meet a 10 to the minus 8 in an urban environment. Can you elaborate a bit on the requirements or the limitations of flying whatever unmanned vehicle or taxis in an urban environment in comparison to standard aircraft and ATC? What are the challenges? What are the difficulties? Where are the limitations?
Yes. So when you look at commercial air traffic and compare it with hypothesized future urban air traffic, the user is very different. When I mean the user, the person operating the machine. On the one hand, in commercial air traffic, you have highly trained professional pilots who have been taught very clearly about how their machine works and about the rules. Whereas in urban air traffic, I think the most that you can expect is some sort of driving test equivalent training for operating these personal aerial vehicles. And therefore, the system has to compensate for this, let's say, the automation used in the system has to still provide the level of flexibility that is available to road traffic to make it appealing for just normal people, everyday people, like all of us here, to use this new aircraft. But at the same time, the system has to guarantee, for instance, the 10 raised to minus 8 safety target level of safety, and that can be achieved by increased automation that essentially makes it very easy for the user simply to set the destination, and then the system essentially calculates everything else, either strategically a little bit and then also a little bit tactically.
You mentioned road traffic, and in your proposition that states that we want to have the flexibility of road in our air traffic environment with UAVs. Yeah. Are you really addressing that we want to accept the safety level that we have on roads today in air traffic? Is that the target that you're looking for? Because this is not probably acceptable from the air traffic side or control view.
That is indeed a good point. I think the proposition has to do with more the planning flexibility side.
Yes.
Safety, of course, we should try to make it as much as possible, probably even higher than road traffic today, because with urban air traffic, the collateral damage could be much higher than road traffic. So it should be higher than road traffic. But the planning flexibility should be at least the same, because otherwise it won't be appealing towards users. And if you were to make it very rigid, my feeling is that the users would disregard your rules and fly it the way that they want. And so you can have all kinds of rules, but they will not listen to them. So for that reason, it would be better to design with that in mind and try to make the system as flexible as possible from a planning perspective.
But this would require a full automation, very high level of automation system available to allow such flexible uses or flexible usability of air vehicles. I jump into my air vehicle and let it fly and don't care about conflict detection or resolution. The system has to do it because I will be unable to do it.
That is indeed correct.
Okay.
And it is the same philosophy as, let's say, autonomous cars. You simply sit inside, you set the destination, and then you start reading your newspaper, and you within a few minutes you arrive at your destination.
Am I allowed for another question?
If you have a short question,
Yeah,
please
sure.
go ahead.
What is the role of the humans? The humans here are operators. We discussed a bit on the operator side, but we have air traffic controllers that take over the responsibility to assure the 10 to the minus 8 at the bottom line. And in your earlier statements, you said that the air traffic controllers, are the limitations. I would say the human is, of course, making the most of the mistakes, but it's the best system still to cope with mistakes and errors and compensate them in this technical system. How do we take care of the air traffic controllers in the future? You said you will not get rid of them, but you will change their role, I guess. What is the changing role of the human as a controller here, not as an operator?
So I would say in a decentralized system, the role of the air traffic controller would be to monitor the safe functioning of the system, to make sure that all the traffic is obeying whatever constraints are, for instance, layered constraints. You have certain aircraft is respecting the heading range that is allowed in that layer, or otherwise advising him to climb or descend to the appropriate layer. So these kind of safety monitoring, and also strategic. So for instance, you do have a capacity limits of decentralized airspace. You would have to start grounding flights when that capacity limit is being reached. So this is another role for the air traffic controller, to anticipate the demand and the capacity and the imbalance between these two, and then decide what to do with the excess demands.
Okay, just one remark. You mentioned monitoring, but you talked about acting and giving adversive maneuvers to the aircraft. So this is a different role. It's not just monitoring; it's also taking deconflict actions.
Deconflicting actions when non-nominal situations occur.
Yes.
Yes.
Okay. Thank you.
You're satisfied
Yes,
with the
I'm
answer?
set. Yes,
thank you
thank
very
you.
much for your position. Then we go to this side of the table, and I give the word to Professor Simons.
Dank u, meneer de rector. Waarde promovendus. I would almost say, and now for something completely different. And that's about the environmental aspects of your simulations. So in section 235, you describe the variables to compare the airspace concepts. And one of these variables is noise pollution, which happens to be my chair at the faculty, as you know. I will start with a few tiny questions which I hope you can briefly answer so that we can clarify a few things. So why did you not include emissions, or if you like, air quality or climate effects, and only noise pollution?
Hoogleer de opponent. Thank you very much for your question. So your question relates to the fact that I used noise metrics in chapter 2, but I did not look at emissions per se. Well, you could say that I have looked at emissions indirectly, because emissions have to do with flight distance traveled, and it is correlated to that. And we have looked at a metric called work done, which is the energy that is expended to go places. And the more work you do, the more emissions you would probably have if you have, for instance, combustion engines or jet engines that we have today doing that work. If you have electrical engines that are using battery power, of course, the amount of emissions that come from a certain amount of work done would not be the same, but it is always correlated to the work done that is occurring.
Okay, yeah, that's clear. So, and the noise model that you use is this INM model that is based on noise power distance tables. Quick question, is that sufficiently accurate for your simulations?
Indeed, the simulations in chapter 2 are using aircraft models that are being created for personal aerial vehicles.
Yeah.
And there are no noise relations for these vehicles.
Nope.
So what we did was we took the INM model, we looked at the maximum allowed noise for tilt rotor aircraft, and we essentially said that is what is allowed for these kind of aircrafts too.
Okay, yeah, that's clear.
So we made a little assumption there.
Yeah, a little. Well, okay. Then in that same paragraph, you have chosen for the 68 dBA level, which surprised me because normally for normal aircraft we use lower levels. And as you realize that a 3 dBA increase or decrease means twice as much you can fly. So a 10 dB higher level. Can you elaborate on the choice for that? Especially in the case of these PAVs?
Yes.
Is that the reason, the PAVs?
Indeed. So indeed in the Netherlands you use 48 and 58 dBA levels.
Yep.
And that has to do with the commercial air traffic, for commercial air traffic. For PAVs and UAVs, they would fly at much lower altitudes and at more inhabited areas. And so the noise pollution element would be more important to analyze, taking this into account. And therefore, we decided to choose the next level, which is 48, 58, 68.
Okay, that's clear. Maybe then a more difficult question, because you clarified all the minor things I had. On page 53, you state that a linear normalization with respect to the total number of flights could not be used as noise is measured in decibels. But is this true? Because you can always go back from dB to linear units, like intensity, for instance, and moreover, your LDEN values can be converted to percentage of people highly annoyed. So if you do that, do you stay with your opinion that you cannot normalize?
If you stick with the dBA, a logarithmic unit, then you shouldn't normalize simply by dividing by the number of aircraft.
No, that's true.
Whereas if you were to convert this metric first into another metric like intensity, then or power ratio, for instance, then you could do this. And perhaps I should have done that.
Yeah, and what about something more simpler? Is that you convert it to percentage of people annoyed, because nobody around an airport understands this LDEN metric.
Indeed.
I mean, it's very abstract.
Indeed. That is indeed another option, to look at percentage of people annoyed. But of course, people are not really aware of personal air vehicles that much. They look at it as a sort of a cool thing, futuristic thing.
Yeah.
But as soon as they start to hear them, perhaps flying over their house, they're not so impressed anymore. So it is very easy that all people would not want this. So the percentage annoyance could be very high. So it would be very difficult to compare the different concepts when everybody's annoyed for all the concepts.
Yeah, that's correct. If I may, I have a final question about this issue.
Sure.
Is that possible?
Please go ahead.
Okay. So if you then go to the conclusions of that chapter, then noise pollution, the one environmental variable that you included in your simulation, is not discussed anymore. So what does that mean? Can you elaborate on that? Because also further on in the thesis, it's not further discussed, as far as I could see.
Noise was only considered in Chapter 2 because of the personal air vehicle aspect, and we're only looking at en route traffic. So because personal air vehicles are expected to fly relatively low, noise is an important factor. But in the rest of the thesis, I look at commercial air traffic and flying at very high altitudes in the en route part, and then noise is not so much of an issue, and that's why it doesn't come back in the rest of the thesis. In the discussion of Chapter 2, I do have a small reference to noise. Basically, I state that the two concepts, full mix and layers, they are indistinguishable with respect to each other in terms of noise and many other metrics. Some metrics, which layers was slightly better, was the safety, for instance.
Okay, I see that. Then I think, but maybe you disagree, that you should then include the climate effects.
Yes.
Do you agree with that?
Indeed, because especially if they are using combustion engines, jet engines for these kind of aircraft, emissions would also affect lower altitudes, indeed. So indeed, that would also be an interesting aspect for future research. Yes.
Exactly.
Yes.
Thank you.
Thank you very much for your position. And then now we go to the co-promoter, Dr. Ellerbroek.
Dank u, meneer de rector. Waarde promovendus, beste Emmanuel. First of all, I'd like to say that I'm very happy to see you standing here now after our years of many discussions, developing closed form models, chasing ghosts like the negative domino effect parameter. And to your credit, I think almost all of the discussions have been concluded with a success. From my perspective, all but one, and that one relates to proposition number 3.
Waarde promovendus, would you like to read proposition number 3?
Proposition number 3. By defining the maximum theoretical capacity of decentralized airspace as the traffic density at which conflict chain reactions become completely uncontrollable, the safety and efficiency of travel are implicitly taken into account without the need for arbitrary weighting factors.
Thank you. So you say that with your method, with your models, you can take so efficiency and safety together without weighing. But so if I compare that to my observations, or rather our observations, with, for instance, conflict resolution algorithm like the modified voltage potential, then if we look at simulations with that method, we see that actually the MVP shows that deliberately generating secondary conflicts, so chain reactions, that can actually lead to more efficient resolutions. So how does that compare to the statements you make with your model?
Dear leader, co-promoter, thank you for your question. I think your question has to do with whether or not there is a contradiction between the statement and, for instance, algorithms such as MVP, which are very efficient because they try to use the minimum path deviation. I think when you look at the whole air traffic system as a whole, and not just particular conflicts, I think on average, conflict chain reactions are always bad. I think the idea that some conflict chain reactions are good and other conflict chain reactions are bad, you could perhaps say that on an individual aircraft level, but on the total picture, I would say that they're always bad because they always increase the flight distance compared to the no conflict resolution case. And the domino effect parameter and the capacity parameter that I'm looking at always compares it to the no resolution case. So even if the resolution is very efficient, and even if that resolution is efficient because it triggered just some few conflict chain reactions, compared to the no resolution case, it's always bad. Now, there are some situations where, like for instance, the famous wall scenario, where a very efficient resolution could be found by creating some conflict chain reactions. However, you should keep in mind that the wall scenario is a sort of a synthetic one, where after the resolution, the aircraft are not required to fly back to their pre-conflict destination. So you have aircraft diverging to create the hole, but you never force them to converge again back to their pre-conflict destination. And I believe that if you were to force them to converge, you would trigger a lot of conflict chain reactions, and that would be very bad for the efficiency.
Thank you very much for your position. And now I give the word to the promoter, Professor Hoekstra, for a very extensive question.
We'll see. Waarde promovendus, it also gives me great pleasure to see you standing here and defending this nice piece of work and this well-written thesis. I have signed for the propositions being defendable, but that doesn't mean I agree with them. So could you read proposition number 7, please? Or I should...
You should ask me?
Yeah, meneer de rector, could you ask the promovendus to read proposition number 7?
Waarde promovendus, would you like to read proposition number 7?
Proposition number 7. Funding agencies should prioritize the originality of a proposal before all other considerations, such as perceived risk and relevance. This approach to research funding is likely to produce results of value.
Please go ahead and ask your question.
So first, to put you a bit at ease, I tend to agree with this proposition, by the way. But I have a question regarding the relevance or the comparison with how we do things today, especially if you look at citations or impact. If you take into consideration how those are treated today, and then look at your proposition again, what do you think the relation would be?
I think in research today, there's always the so-called hot topics. And if you're working in so-called hot topic areas, no matter what you write, you will get a lot of citations because, well, it's a hot topic, everybody is interested in it, and as a result, if you make one or two clever statements in your paper or so, you will be cited somewhere. On the other hand, even if you have a very original idea in a non-hot topic area, well, your paper may never be read or perhaps never be cited. And I think that reflects on this proposition where because there's this sort of emphasis on hot topic research that are being funded, the non-hot topic ones, which are still relevant, are not getting the funding that they deserve.
On the other hand, you could also say, and
Thank you, Madam Beadle. I request the promovendus to take a seat again. The committee will now withdraw for further deliberation in the committee room, and the session is adjourned.
photo from this.
I reopen the session and request the promovendus to stand in front of the committee. Het College voor Promoties van de Technische Universiteit Delft, vertegenwoordigd door de hier aanwezige commissie, heeft, na kennis te hebben genomen van uw proefschrift met stellingen en na uw verdediging daarvan te hebben gehoord, met inachtneming van het bepaalde in de Wet op het Hoger Onderwijs en Wetenschappelijk Onderzoek, besloten u de graad te verlenen van dokter. Ik verzoek de promotor door het College voor Promoties als zodanig aangewezen zich wel van de hem opgedragen taak te kwijten.
Uit kracht van de bevoegdheid bij wet toegekend aan het College voor Promoties verklaar ik namens dat college, hier vertegenwoordigd door de rector magnificus en de overige leden van de commissie, bij deze u, Emmanuel Sunil, te bevorderen tot dokter en u alle rechten te verlenen welke aan de dokterstitel zijn verbonden. Ten bewijze hiervan overhandig ik u het diploma dat u het recht geeft de titel dokter te voeren, ondertekend door de rector magnificus en de promotoren en voorzien van het zegel van de Technische Universiteit Delft.
It is the promotor's privilege to be the first to congratulate the young doctor, Professor Hoekstra. The floor is yours again.
Dear Emmanuel, dear Dr. Sunil, when we many years ago heard that the Metropolis project was awarded, and we could start looking for a PhD student, and Max Mulder actually recommended you, and after we met, we both decided that this indeed might work for you and for us. The project we started with was a very futuristic project. But as we both know, this was really just a sort of cover-up storyline to tackle a very fundamental, almost mathematical question regarding airspaces. When are they full? Well, this sort of mathematical fundamental question make it sound a bit dull, but I think the project was far from that for two reasons. Well, first of all, and I've heard you also say that we really had a very nice team, I think, with NLR, DLR, and ENAC. And secondly, of course, we had to simulate still those scenarios from the storylines. So we were sitting together where we had to think about sometimes very strange questions like, where and how would you land a personal vehicle in Paris? And how a drone would deliver a package. And I also saw you enjoying those sessions with, as if it was like philosophizing with a number of friends, actually. During the course of the project, it became less and less futuristic as many prototypes were suddenly flying and large companies expressed interest in exactly the kind of applications we were looking at. I think what typifies you, Emmanuel, is that you used this opportunity, this project, not just as input for the first phase of your PhD research, but also to make friends. You spent many days at NLR with Frank Bussink, trying to get all these ideas of the partners into really actually running scenarios, which often meant you still have to do a lot of detailed design actually as an add-on, as a result of the initial simulations. But also in the final phase of your PhD, you as a result went to ENAC to spend a sort of short sabbatical there to finish your thesis. And I think this is typical for you. Everywhere you go for a project, sabbatical, or for a meeting, you're able to make friends. And I think this is because it's such a pleasure to cooperate with you. As an example, typical Dutchmen will immediately tell you when you say something that they don't agree with. It doesn't take, it's a fraction of a second, I would say. And despite living in the Netherlands for many years, I think you still have a different and probably even more effective approach. When you say to Emmanuel something that he doesn't agree, that before he enters, he doesn't say no or something. He says, interesting. I recently heard that actually this is sort of British attitude, but then, interesting. And so you feel happy and he says something interesting. But what he does then, he goes back to his office, programs a complete simulation, tests this a few times, then adds millions of flights, runs the complete weekend again, and then the next Monday, he comes into your office and say, remember you said last week, but it seems like, And then if you try to argue against it, you'll get this staggering amount of data, accumulated data over the weekend, shown on many graphs, and you don't really have a chance to argue. I think this is typically Emmanuel. I think we also saw that today the committee commented that you thought this excellent defense, you were well in control. Maybe you thought to yourself, interesting, some of those questions. And then you threw at us many reasonings and many data to convince us in a way that the committee agrees you did very convincing. And it's also typical, I think, that Emmanuel also always not just in control, but seems calm. I mean, he's not just a friendly colleague with good manners who's able to research and build simulations, but he's also, and this comes with this calmness, I think, very, very thorough. And I mean, every assumption of your work was tested. Every derivation for your mathematical was proven to be true or false, also with empirical results. And even the ones that we thought sometimes were obvious at first sight were put to the Emmanuel test. And in this way, we even learned sometimes very surprising things. And not just about the main research questions, but also how you should really build good traffic simulations, for instance, and resulted in a paper on that, without any artifacts. Because every strange turn in the graph that turned up was investigated with scrutiny until you fully understood the cause. And when, after Emmanuel finished his thesis against a tight deadline of being employed, he started working at NLR, where I think you will be, I said will be, but I'm sure you already are, a great asset. And I have no doubt about that they're going to be happy with you, or they are happy with you. And having spent 16 good years there myself, it also gives me great pleasure to confidently wish you not just a lot of success, but also a lot of pleasure there doing the type of work you're good at and which you love. Congratulations.
I now have a few final but nevertheless important words to you. Learn, Dr. Sunil. You now have the right to use the title of doctor, and your doctorate means that society can rely on your judgment, that you will act transparently and communicate independently about your results, and the social relevance of your work. In other words, your doctorate implies that you will uphold scientific integrity. I wish you a great deal of wisdom and prosperity with your new degree. And on behalf of the Board for Doctorate of Delft University of Technology, I congratulate you and your family on earning your doctoral degree. Dr. Sunil, you may return to your seat. Ladies and gentlemen, I thank you for your presence, and I hereby close this academic session.